first, we're going to have to think of angles as rotational angles, which means that this here is 0 degree. And I don't know, it reminds me of in action movies when you see the radar looking for things, the angle is just going around, going around. But this is not an angle, this is a ray, right? This is the positive direction. And so 190 will not fit into a triangle, but it would fit here. How would 190 look like? Well, this is, you start rotating in the positive direction, 90, another 90, this is 180, and then 10 degrees more. See, that is going to be right triangle trigonometry, but that has to do with degree 10. But this point here, or this ray here, will represent, not 180, I'm sorry, 190 degrees. Terrible. Okay. What about negative 100 degrees? Negative 100 degrees, where would that be? Well, this is the negative direction, go 90, and then guesstimate 10 more degrees. So, but you see there are two things here. There is an angle small enough to fit in a triangle, 10 degrees, which will have to do with stuff, but this point itself is representing negative 100 degrees. Or what if we approach this point from here? Can you tell me what angle would that be? Well, you can say, okay, 90, 180, 270, go back 10, 260. Or you can say, well, this is 100, so this has to be the other 260, right? So nothing is for free. With rotational angles, we can think of any number, stick a degree sign after it as an angle, but there is payment for it. We have to pay dearly for it. There are now infinitely many angles that basically land us on the same point. This point could represent negative 100 degrees or 260 degrees, or set 360 to it, or add another 360, or start subtracting 360 degrees. Now, these angles, so each point or each ray represents an infinite family of angles that differ by a multiple of 360 degrees. Maybe we should go to a simpler example, like, okay, what about 20 degrees? 20 degrees is here. This is a 20 degrees, but what about if we go a full circle and then 20 degrees? What angle is that?
380.
380.
Yeah, 380. And then we can add again one. We can add again one, and then we can subtract them. In fact, now we're going to be in trouble because when we solve an equation, we have to find all the solutions. So now we're going to have to, every trigonometric equation, if it has one solution, it will have infinitely many. This family of angles are called coterminal because the ray terminates on the same thing. And coterminal angles have the same everything. Sine, cosine, tangent, everything. You can't tell one from the other, not from tangent or sine. What about the negative angle, coterminal to 20? Make a negative full lap, and then, or this is negative 90, negative 180, negative 270.
Would it be negative 340?
Yes, it would. It would. This is negative 360, but let's stop 20 shorter. So it's negative 340. So these angles are called coterminal angles. We're going to write 20 degrees plus k times 360 degrees, where k has to be an integer. This has to be a full lap, one way or the other. But saying that k is an integer is really sloppy. No, this k is not a fixed integer. This is a variable that has to run through all integer values to pick up all these coterminal angles. So here is k, here is 20 plus k times 360. If k is 0, what angle do we get out of this? Putting k equals 0 into this.
20 degree.
20. Put in there, oh, I'm sorry, that's my bad. Put in there k equals 1. What angle do we get?
380.
K equals 2.
740.
720, 740, yes. What about -5? K is -5.
Negative 1780.
Yes. Okay. So if we're going to solve an equation, a trigonometric equation, where the answer, one of the answers is 20 degrees, then you have to find all the answers. These all going to be solutions. So that's the payment we have to pay for enlarging the domain of these trigonometric functions.